This video is about proving and using the formula for the sum of n terms of a geometric series. We need to be able to solve complex worded problems involving geometric series as well. So in a geometric series, if a is equal to the first term, r is equal to the common ratio, n is equal to the number of terms, then the terms of the sequence of the geometric sequence are a times r squared, a times r cubed, all the way up to a times r to the power of n minus 1. Then Sn will be a plus ar plus ar squared plus ar cubed plus dot 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 plus up to the last term, which is ar n minus 1, which is the nth term. Also, r times Sn will be a times r, which is just ar, plus a times r, ar times r, which is ar squared, plus ar cubed, plus blah blah blah. Ar to the power of n minus 1 times by r gives you plus ar to the power of n, because you increase the power of r by 1, so you get ar to the power of n. And one previously, that would be ar to the power of n minus 1. Then if we call this equation 1, and we call this equation 2, then 2 take away 1 becomes, in the left hand side, r times Sn take away Sn. And then it's 2 take away 1, so it will be ar plus ar squared plus ar cubed plus dot 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 plus ar to the power of n minus 1 plus ar to the power of n. Take away 1, which is a plus ar plus ar squared plus blah blah blah, all the way up to ar to the power of n minus 1. And when you subtract these two things, you realize ar and the ar cancel out, ar squared, ar cubed, so on. And all you're left with are two terms on the right hand side. So you're left with rsn take away sn on the left hand side, and a times r to the power of n take away a. Now you can factorize both sides. So if you factorize the left hand side, you get Sn times r minus 1, which is equal to a times r to the power of n minus 1, which means Sn is equal to a times r to the power of n take away 1 over r take away 1. And that is the formula for the nth term of a geometric series. Now this is also equivalent to a times 1 minus r to the power of n over 1 minus r. So they're the same thing. Now let's go through some examples of using this formula. So let's find the sum of the first 6 terms of the following geometric series. So here I know a is equal to 1, 4, 5, 8. R will be equal to second term, which is 4, 8, 6, divided by first term, which is 1, 4, 5, 8, which gives me a third. Number of terms is 6. Sn is what we're trying to find out. So using Sn is equal to a times 1 minus r to the power of n over 1 minus r. S of 6 will be equal to 1458 times 1 minus a third to the power of 6 all over 1 minus a third. So if you put that into your calculator, you get 2184. A geometric series with 9 terms has common ratio -4. The sum of the series is 209,716. Find the first term of the series. So we know n is equal to 9 in this case. R is equal to -4. We know S of 9, because we've got 9 term, is equal to 209,716. We're trying to find the first term. So using Sn is equal to a times 1 minus r to the power of n over 1 minus r. You get S of 9, which is 209,716, is equal to a times 1 minus 4 to the power of 9, all over 1 minus 4. So what you end up getting in the denominator is 5. So because it's dividing by 5, if you take it to the other side, you get 5 times 209,716 will be equal to a times 1 minus 4 to the power of 9. So if I want to find a, all I have to do is 5 times 209,716 all over 1 minus 4 to the power of 9. So just rearrange to make a the subject of the formula. When you put this into your calculator, you get a is equal to 4. A geometric series has first term equal to 5. So a is equal to 5. Common ratio is 4. So r is equal to 4. The sum of the series is 109,225. So Sn is equal to 109,225. Find the number of terms. So n is equal to question mark. So using Sn is equal to a times 1 minus r to the power of n over 1 minus r. Then I know 109,225 is equal to 5 times 1 minus 4 to the power of n all over 1 minus 4. So I know the denominator is -3. So I can multiply 109,225 by -3. And that will be equal to 5 times 1 minus 4 to the power of n. In my calculator, I get -327675 is equal to 5 times 1 minus 4 to the power of n. If I divide by 5, I end up getting on the left hand -65535 is equal to 1 minus 4 to the power of n. So if I take -4 to the power of n to the other side, and I take the -65535 to the right hand side, then I get 1 plus 65535, which is equal to 65536. 4 to the power of n, that should be not 4n. So 4 to the power of n is equal to 65536. So log of 4 to the power of n is equal to log of 65536. So n log of 4 is equal to log of 65536. So n will be equal to log of 65536 divided by log 4. And that gives us a value of 8. So n is equal to 8. Problem solving using some notation. So we're trying to work out these summations, so a, b, c, and d. So for a, I'm working out r equals 1 to 6, 4 to the power of 1, so it's 4 to the power of r, so it's 4 to the power of 1 plus 4 to the power of 2 plus 4 to the power of 3, all the way up to 4 to the power of 6. In this case, we have a is equal to 4, because that's the first term, 4 to the power of 1. R must be equal to 4, because we're multiplying by 4 each time to get the next term. And n is equal to 6 terms. So using Sn is equal to a times 1 minus r to the power of n over 1 minus r. We get S of 6 is equal to 4 times 1 minus 4 to the power of 6, all over 1 minus 4. 1 minus 4, which gives me, in my calculator, 5460. Let's look at the next example. The sum r equals 1 to 8. 2 times 3 to the power of r. So the first term will be 2 times 3 to the power of 1, plus 2 times 3 to the power of 2, plus 2 times 3 to the power of 3, all the way up to 2 times 3 to the power of 8. So in this case, we have a is equal to 2 times 3 to the power of 1, which is 6. R is equal to, we're multiplying each term by 3 to get the next one. So R is equal to 3. And N is equal to 8, because 1 to 8, there's 8 terms. So again, using Sn is equal to A times 1 minus R to the power of N over 1 minus R, we get S of 8 is equal to A, which is 6 times 1 minus 3 to the power of 8, all over 1 minus 3, which is equal to 19680 on our calculator. Okay, if we do C now, the C is sum R equals 1 to 10, 6 times a half to the power of R. Then the first term is 6 times a half to the power of 1, plus 6 times a half to the power of 2, plus all the way up to 6 times a half to the power of 10. So in this case, my A is 6 times a half to the power of 1, which is 3. My R is I'm multiplying by half each time, so R is equal to half, and my N is equal to 10, because there's 10 terms. So using S of n is equal to A times 1 minus R to the power of n over 1 minus R, I get S of 10 is equal to A, which is 3 times 1 minus a half to the power of 10 over 1 minus a half. I put that into my calculator, I get 3069 over 512. For D, we got sum R equals 0 to 5 of 60 times minus the third to the power of R. Okay, which means the first term will be 60 times minus the third to the power of 0, plus 60 times minus the third to the power of 1, plus all the way up to 60 times minus the third to the power of 5. So in this case, I've got A is equal to 60 times 1, which is 60. My R is equal to minus a third. And my N, be very careful with N. I'm starting from 0 all the way up to 5. So I've got 0, 1, 2, 3, 4, 5. So that's 6 terms. So just be very careful with that. N is equal to 6. So using Sn is equal to A times 1 minus R to the power of N over 1 minus R. Get S of 6 is equal to 60 times 1 minus a third to the power of 6, all over 1 minus a third. Which means if I put this into my calculator, I get S of 6 is equal to 3640 over 81. Okay, next question. A ball is dropped from a height of 10 centimeters, so that means that is 10. It bounces to a height of 7, so that one will be 7, that one will be 7, and continues to bounce. Subsequent heights to which it bounces follow a geometric sequence. Find out A, how high it will bounce after the fourth bounce. So that means after the first bounce is 7. So 10 is the first, so 10 is the first term, then 7, then blah, blah, blah. Where A is equal to 10 and R is equal to 7 divided by 10, because if this is R, then we have to do second term divided by first term to get R, which is equal to 0.7. So that would be the first one, which is A is the first term. A times R gives you the first bounce, the height after the first bounce. So if I want to find the height after fourth bounce, then it will be AR to the power 4, which is equal to 10 times 0.7 to the power of 4, which if I put into my calculator, I get 2.401 meters. B, the total distance traveled until it hits the ground for the 6th time. Okay, so if I'm looking at the ground for the 6th time, so this is the 1st time, 2nd time, 3rd time, 4th time, 5th time. So the next one, which is 6th time. So I need to work out S of 6 basically. So we've got 10, 7, so on. So we're trying to find out N is equal to 6, A is equal to 10, R is equal to 0.7, then S of N is equal to A times 1 minus R to the power of N over 1 minus R, which implies S of 6 will be equal to 10 times 1 minus 0.7 to the power of 6 all over 1 minus 0.7, which gives me 29.4117 meters. But that is counting each bounce once. So what it's done is it's counted the, if I use a different color, red, no, not red actually, let's use green. So it's counted this once, all the bounces once. So what I need to do is I need to double it. So if I double it, then I'm going to get everything doubled, but then I'm going to get this 10 doubled, which I don't want here. So all I need to do is double 2 times S of 6, but I need to take away 10 because I don't want the 10 at the beginning. So it's the same thing as 2 times 29.4117, take away 10, which gives me a value of 48.8234 meters. So that would be my answer. Next example, find the least value of n such that the sum 5 plus 4.5 plus 4.05 blah 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 to n terms would first exceed 45. So the first term, a, is equal to 5. The common ratio is equal to the second term divided by the first term, so 4.5 divided by 5, which is equal to 0.9. N is equal to question mark, which we're trying to find out. And we want the sum of n terms to be greater than 45. Okay, so using Sn is equal to a times 1 minus r to the power of n over 1 minus r, we get 5 times 1 minus 0.9 to the power of n over 1 minus 0.9 is greater than 45. Okay, the bottom part is equal to 0.1. 5 divided by 0.1 is 50. So you get 50 times 1 minus 0.9 to the power of n is greater than 45. If we divide both sides by 50, we get 1 minus 0.9 to the power of n is greater than 45 divided by 50, which is 0.9. Okay, if we take one takeaway to the other side, so if I make this 1 takeaway 0.9, then it's greater than 0.9 to the power of n, which means 0.1 is greater than 0.9 to the power of n. We take logs on both sides, so log 0.1 is greater than log 0.9 to the power of n, which means n times the log 0.9 must be less than log of 0.1. Okay, if we divide by log 0.9, then because the log of 0.9 is a negative number, it will flip over, the inequality will flip over, so you end up getting n is greater than log of 0.1 divided by log of 0.9, which means n is greater than 21.8543 from our calculators, which means n must be equal to 22. Next question. Richard is sponsored to cycle 1,000 miles over a number of days. He cycles 10 miles on a day 1 and increases this distance by 10% a day. How long will it take him to complete the challenge? So A is equal to, first term is 10. So it's 10 miles. The common ratio, because it's increasing by 10%, the multiplier is 1.1. So 1.1 is the common ratio. N is equal to question mark. And the sum of n terms, we want it to be 1,000 miles. So using Sn is equal to a times 1 minus r to the power of n over 1 minus r. You get 1,000 is equal to a, which is 10 times 1 minus 1.1 to the power of n, all over 1 minus 1.1. This just becomes equal to negative 0.1, and 10 divided by negative 0.1 is equal to minus 100. So I've just simplified that part. So if I divide by 100, I end up getting 10 is equal to minus, so if I divide by 100, minus 1 minus 1.1 to the power of n, which means 10 is equal to minus 1 plus 1.1 to the power of n, which if I take the negative 1 to the other side, I get 11 is equal to 1.1 to the power of n. Because n is in the power, so my unknown is in the power, so I need to take logs on both sides. So log of 11 is equal to log of 1.1 to the power of n, which means log of 11 is equal to n log 1.1. So n is equal to log 11 divided by log 1.1, which means n is equal to, if I put this into my calculator, n is equal to 25.1588 blah blah blah. So it's more than 25 days, so n must be equal to 26. Now there is a second part to this question. It says, what was the greatest number of miles he completed in a single day? Since n is equal to 25.1588 blah blah blah, it means obviously he didn't cycle much on the 26th day, so the highest one will be, greatest number of miles will be on the 25th day. So it will be the greatest number of miles will be on the 25th day. So we need to work out U25. So U25 is equal to A, R, n minus 1, which is equal to 10 times R, which is 1.1 to the power of 24, which is equal to 98.4973, which gives us a value of 98.5. So that on the 25th day, that Richard cycled for 98.5 miles. If you don't quite believe that it's the 25th day and you think it might possibly be 26th day, what you can do to work out how much he cycled on the 26th day is work out S of 25, which will be equal to 10 times 1 minus 1.1 to the power of 25 over 1 minus 1.1, which gives you 983.47. So that's how many miles he cycled up to the end of the 25th day. So U26 will be equal to 1,000 miles, because that's how much he had to cycle, take away 983.47, blah, 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 which is equal to 16.529 miles, which is obviously not more than 98.5, so it doesn't work out. Next question. A savings scheme is offering a rate of interest of 3.5% per annum for the lifetime of the plan. Alan wants to save up to £20,000. He works out he can afford to save £500 every year, which he will deposit on 1st January. If interest is paid on 31st December, how many years will it be before he has saved up to £20,000? So if we think about, we got year 1, year 2, year 3. We've got money being paid on the 1st of January, and then we've got interest being paid on 31st December. So in year 1, you'll have £500 put in. By 31st of December, it'll be 500 times 1.035, because there's an interest of 3.5% per annum. The second year, you're going to So Alan's gonna put an additional 500 in, but then the money from 31st December will be brought forward. So it'll be 500 times 1.035. Now by the 31st of December, this amount in January 1st, which is 500 plus 500 times 1.035, will also times by 1.035. So you end up getting 500 times 1.035 plus 500 times 1.035 squared when you multiply out the bracket. Let's just do one more to see the pattern. So the following year, you're going to have 500 added again, and then plus the amount from 31st of December, which is 500 times 1.035 plus 500 times 1.035 squared. Again, this amount will multiply by 1.035, so you end up getting 500 times 1.035 plus 500 times 1.035 squared plus 500 times 1.035 cubed. So you can see a pattern now. So A is equal to the first term, which is here, which is 500 times 1.035. Your ratio, common ratio, is every time you're multiplying by 1.035 again. So is 1.035. Your n is equal to question mark. You're trying to find out how many years it will take for the Sn to be 20,000 for Alan. Okay, so using Sn is equal to A times 1 minus Rn over 1 minus R, you get 20,000 is equal to A, which is 500 times 1.035 times 1 minus 1.035 to the power of n, all over 1 minus 1.035. So you get 20,000 is equal to 500 times 1. Okay, I can put 500 times 1.035 into my calculator. So if I do that, I get 517.5. The bracket stays as it is. All over, I get negative 0.035. If I divide both sides by this, or if I times by negative 0.035, so if I times by negative 0.035 and I divide by 517.5, then I end up getting in the left hand side is minus 280 over 207 is equal to 1.1035 to the power of n. I'm just going to end up going over here. If I take the negative 1.035 to the power of n to the left hand side, I take the other one to the other side, I get 1 plus 280 over 207, which gives me 1.035 to the power of n is equal to 487 over 207. If I take logs now, log of 1.035 to the power of n is equal to log of 487 over 207, which means n log of 1.035 is equal to log of 487 over 207. So n will be equal to log of log of 487 over 207 divided by log of 1.035. I put that into my calculator, I get n is equal to 24.86947, which means n is equal to 25. So at the end of 25 years, he'll have saved up 20 grand. Ball is dropped from a height of 2 meters. After each bounce, it rebounds to a height 0.8 times the height that it reached after the last bounce. So it's times by 0.8, 2 times 0.8 is 1.6, times by 0.8, so on. So this is the first bounce, after first bounce. After how many bounces does the ball first rebound to less than 10 centimeters from the ground. That means I'm going to start off with 1.6, so that's after my first bounce. So 1.6 and then 1.6 times 0.8, 1.6 times 0.8 squared, blah, blah, blah. So A is equal to 1.6. R is equal to 0.8. N is equal to question mark. And S of N is less, sorry, not S of N, sorry, because I'm trying to find which bounce exactly. It'll be U of N is less than 10 centimeters. But remember, it was originally measured in meters, so that means U of N is less than 10 centimeters in meters is 0.1 meters. So using UN is equal to AR and to the power HR and to the power of N minus 1. Then we have 1.6 times 0.8 to the power of N minus 1 has to be less than 0.1 meters. Which means 0.8 to the power of N minus 1 must be less than 1 over 16 when we divide both sides by 1.6. Log of 0.8 to the power of N minus 1 must be less than log of 1 over 16, which means N minus 1 of log of 0.8 must be less than log of 1 over 16. These numbers are less than 1, which means it's a negative number, so when we divide by log 0.8, the inequality will change direction, so N minus 1 must be greater than log of 1 over 16 divided by log of 0.8, which means N minus 1 must be greater than 12.4251 from our calculators, which means N must be greater than 13.4251, which means N must be equal to 14. Therefore, first bounce to be less than 10 centimeters is the 14th bounce.